Hi guys, it's your guy Olumde, and today we're gonna be solving another one of the most commonly asked tech interview question, the prerequisites. It is a DSA problem that is commonly asked by top tech companies including Google, Amazon, Netflix, Meta, Microsoft, Apple, and other top tech companies. The problem statement states that given an integer n representing the number of courses labeled from 0 to n minus 1 and an array of prerequisite pairs, determine if it's possible to enroll in all courses. So this problem is actually specifying that we have a list of courses, n courses to be precise, and the n value is going to be given to us as an input. So we're going to be given the number of courses, and these courses are labeled 0 to n minus 1, and then we are also given a prerequisite pairs that actually represent a pair a comma b, indicating that course A must be taken before course B. So and we now want to return whether true or false if it is possible to enroll in all courses. So we are giving this particular example input. So actually it will not be given to us in graphical form. It will only be given to us in terms of the number of courses n and the prerequisites, that is the pair, the order in which these courses are going to be enrolled. So we say that in the prerequisite we are given 0, 1, which represents the pair 0, 1 that you can see on this screen. So it's actually ordered, meaning that it is directional. So what it means is that we have to do course 0 before we do course 1. So course 0 needs to be taken before course 1. Similarly, we have 1, 2 now, which means that course 1 then have to be taken before course 2, and then we have in this prerequisite we have the last pair to be 2, 1, indicating that course 2 have to be done before course 1. But you see, there's actually a problem here, because there's no way we are gonna do course 1 before course 2 and then do course 2 before course 1. So, and that's why the output here is false, because there's no way we can enroll in all of these courses if we have to enroll in course 1 before course 2, and at the same time we have to enroll in course 2 before course 1. So the explanation here is that course 1 cannot be taken without completing course 2, and the same thing applies to course 2 cannot be taken without completing course 1. So therefore there is no way we can enroll in all of these courses. So the constraint that is given to us is that for any prerequisite a comma b, a will not be equal to b. So it's just an explanation, it's just if it's just additional detail that for any prerequisite the same course will not be a prerequisite to the same course, meaning that there won't be any case whereby a comma b is the same thing as b comma a, whereby, okay, imagine now saying that we have a prerequisite of 0, 0, whereby course 0 have to be done before course 0. So there won't be something like this in the input that will be given to us. Our goal in solving this problem is to check if enrollment into all courses is possible. So let's consider situations whereby and scenarios whereby enrollment into all courses are not possible. Let's first of all consider a simple version whereby we only have 2 courses. So enrollment to all courses is going to be impossible if each of these 2 courses actually are prerequisites to themselves, meaning that this let's call this course 0, right, and this course 1. So this course 0 is a prerequisite to course 1, and course 1 is a prerequisite to course 0. So just like we can see in this prerequisite list, 0 comes before 1, indicating that 0 is a prerequisite to 1, and at the same time 1 comes before 0. So that way it is impossible. Now for a scenario whereby we have 3 courses, now it will be impossible to enroll into all the courses in these 2 scenarios whereby we have 3 courses. You see that here fine, 0 is a prerequisite to course 1 and 1 is a prerequisite to course 2, but 2 also is a prerequisite to course 1 at the same time, just like we can see in this diagram here and in the prerequisite list. Similarly for this one too as well, we see that 0 is a prerequisite to course 1, 1 is a prerequisite to course 2 and 2 is a prerequisite to course 0. Therefore, because of that, there is no way we want to first, you see that 2 is actually a prerequisite to course 0, right? Meaning that we have to do course 2 before course 0, and now we can then do course 1 after doing course 0, but there's no way we want to do course 1 and course 2 without doing course 1. So it actually forms a loop, and that is one observation we can find in prerequisite that couldn't work. I mean, in courses that could not really be enrolled for entirely. So is that there will be some sort of loop, there will be a cycle, they will form a circular shape, they'll form a circular relationship, so in such a way that one cannot be done without the other, and at the same time the other cannot be done without one. So that's one key and major observation for courses that could, or for scenarios whereby all the courses cannot be enrolled for. Another observation that we could find out is that whenever I want to solve this problem, one place we start from are those courses that do not have any prerequisite, right? So fine, you see that when we are trying to solve this, when we are trying to explain this, I first start from 0, fine, because it seems as if there's no imagine this scenario here now. At this point here, 0 does not have any edge pointing at it, so it's a good place to start, right? Meaning that whenever we're trying to search whether it can be enrolled for or it cannot be enrolled for, it's a good place to start from a node or a course that actually does not have an edge, that is a course that actually could be taken at any time. Just like in this case, we see that 0 could be taken at any time because it actually does not have a prerequisite, but 1 do have a prerequisite, which is 0, and at the same time 2 have a prerequisite, which is 1, and 1 also have a prerequisite, another prerequisite, which is 2. So 2 observations: whenever they form a loop like a circle or they have a circular shape, it cannot be enrolled automatically, and also a very good place to start solving from is a point whereby that particular course does not have a prerequisite. Now let's consider this particular example whereby we have 6 courses. We have 6 courses from label 0 to 5, right? So these are the 0, 1, 2, 3, 4, 5, right? And then let's define a variable that we'll call in degree. So this in degree actually represents the number of edges that is pointing to a particular courses, that is the number of dependencies for that particular course, right? So meaning that course 0 is going to have an in degree of 0, right? And course 3 is going to have an in degree of 0. Why? Because they actually does not have any edge pointing at them. So similarly, course 1 is going to have the in degree of 1, and because it actually have just one course pointing at it, meaning that it has just one dependency. Similarly, course 2 have 2 dependency, which is course 0. So actually what I mean by dependency is prerequisite, right? That is the course that has to be done before course 2 could be done. So, and that's course 0 and course 3, right? So similarly for course 4 has 2 dependency, which is actually course 2, course 1 and course 2, and course 5 has a single dependency, which is depend on course 4. So you can see all of this thing right here, that course 5 actually depend on course 4, but seeing course 4 depend on course 2 here, and also depend on course 1 right here. Similarly, course 2 depend on course 3, and it depends on course 0. Course 1 depend on course 0, right? But course 0 and course 3 actually does not depend on anything. So now let's first treat course 1 and course 2. I mean, let's enroll for these courses now. So when we enroll for it, then we can move them out of our graph, right? Because now they have been enrolled for. So, and then one thing we notice is that as we move them and as we enroll for them, the prerequisite for course 1 and course 2 will reduce. Why? Because now course 0 has been enrolled for, so it is no more a problem for course 1. So course 1 that actually have a prerequisite of 1, which is course 0, will now have a prerequisite of 0. Why? Because the course has been enrolled for, right? Course 2 also have a prerequisite of 2, which is course 0 and course 3, right? And because we have actually enrolled for these 2 courses, reason being that they have zero prerequisite because they have no edge connecting to them. So course 2 also becomes 0 because course 2 0 and course 3 have been done. So and now we have this new graph, right? Now looking at this graph, one thing we can observe is that even course 1 and course 2 now have 0 in degree, meaning that they actually does not have any edge pointing at them. They have no prerequisites anymore because their prerequisites have been enrolled for. So meaning that we can also do them. We can also enroll for these two courses now, and enrolling for them now will make them disappear from the graph, right? And then we have course 4 right now, and this course 4 is going to be having 0 prerequisites. Why? Because its prerequisites 1 and 2 have been enrolled for. So similarly now, it means that we can now enroll for course 4. Why? Because it has 0 prerequisite now. So and automatically course 5, which actually is depending on course 4 now, because course 4 has been enrolled for, it now has 0 prerequisite as well. And then that's how we actually solve this problem, and we can for this particular example, and therefore we can return true that here all the courses can be enrolled for, because one by one we are able to enroll for each and every one of the courses. Let's consider this particular example whereby it seems impossible to enroll for all the courses. You will see that it's similar to the first example, this particular example here, but now there's a connection between node 5 and node 2. Sorry, you can call it node, you can call it courses. So in the case of this particular, we are dealing with graph, right? If you go look at my subsequent video, I've been talking about graph for quite some time now, so you can go look at other graph related problems that I solved on my YouTube channel, right? So but now because we are dealing with courses, so I'm not gonna call it node, let's call it courses, right? But pardon me if I call it node sometime. So now let's say we connect course 2 and course 5 together now. Definitely that brings about a circle, right? And because of that, we already talked about that whenever it forms a circle like this, definitely it cannot be enrolled for course. Imagine, well, we are gonna look at it why it cannot be enrolled for. So fine, we are gonna enroll for 0 and 3 because they have no prerequisite now, and because of that we are gonna reduce the prerequisite for this course 1, which is actually depending on course 0, but because course 0 have been enrolled for, now we can enroll for the prerequisite or in degree of course 1 is 1, and because we have enrolled for that one, it can now become 0, right? Similarly, course 2 will become it's actually 3 here. Let me update it. So it's actually 3 here because it's actually depending on course 0, course 3 and course 5, right? And now because we've enrolled for course 5, because we've enrolled for course 0 and course 3, so it's in degree now reduced to 1, right? Because we enrolled for 2 courses, but you see we've not enrolled for course 5, so it remains 1, right? And we cannot enroll for course 5 unless its own pre-degree is 0, but you can say that its pre-degree is actually 1 because it actually depends on course 4, and course 4 depends on 2 other courses, so we can't yet enroll for course 5. So meaning that the in degree of course 2 remains 1. So now, but in degree of course 1 is 0, right? So we can enroll for it now. So enrolling for it is gonna give us this diagram right here, but you will notice that at this point, let me update this here to become 1, right? So you will notice that now course 4 actually depend on course 2, right? So its in degree is 1, indicating that we cannot yet enroll for it. Similarly, course 2 have an in degree of 1 because it's depending on course 5, indicating that we cannot yet enroll for it as well. Definitely there is no way we want to progress from this graph. Why? Because none of them have an in degree of 0, right? So, and that means we are going to be returning false in this case. Why? Because in this case, why? Because there's no way we're gonna enroll for all the course. We get stuck right here, right? So meaning that this is very fine, a very fine approach to solving this problem. In order to solve this problem, we call it the topological sorts. So and we can solve we can use Kahn's algorithm to solve this problem. So because it actually involves and require ordering of courses, and enrolling from courses in order according to their edges. So it's actually called being formal, we call it the topological sort, and you can use the Kahn algorithm to solve it. So now let's go on to see how this works. So don't forget, we've been talking about the in degrees. The in degrees actually represent the number of edges that are connected to a particular course or a particular node, right? So now first of all, let's consider this example, right? So let's now use the Kahn algorithm to solve it. We have the prerequisite given to us, right? And it's through the prerequisite that we're able to draw this visual. So in code now, there's no way we wanna draw this. We're just gonna utilize this prerequisite list, right? Because this is just a visual diagram for your understanding, just to make it more explanatory, right? So we're going to be defining this in degree. It's going to be a list of integers, so whereby each index actually represents the courses. So index I represents course I, and then the element at index I actually represents the number of edges that are connected to that particular course, meaning that the number of prerequisites of that course, that is the number of courses that course is depending on. Consider course 1 now. You see that it's actually depending on course 0, which means that it has just one prerequisite, right? So that's why the in degree is 1 right here. So if you look at course 1 also here, it's just 1, or in the in degree list it's just 1. So considering course 2, the in degree is 2. Why? Because it actually depends on 0 and 3. So if you look at it, if you look at this arrow, it's pointing to the first one, which is 0 here, and the second one, which is 3. Why? Because it's dependent. So if you look at course 3 is actually depending on 0. Why? Because it actually does not have any in degree, does not have any edge pointing at it. Similarly, if you look at course 4, you see that course 4 is actually depending on course 1 and course 2, so it has 2 in degree, and course 5 has 1 in degree. So in terms of code now, because we can easily see it as illustrated in this diagram, but in terms of code, what we're going to be doing is that we're going to be iterating through the pre-degree, so I and j for each of the indices of the list. So we see that we have I and j. So and then anytime we found out the j, we are going to increment the in degree for that particular j by 1, meaning that imagine we found 1 here, we are going to increment the element at position 1 right here, and that's why we have 1. So they are all going to be set to 0 by default. So it's like we are going to find, since we know the total number of courses n, we can just populate the in degree to be 0 n's, right? So but anytime as we iterate through the p degree here, anytime we come across, for each j we come across, in fact it means that it actually have a dependent, right? So and that means that for this one now we're gonna increment it, and it's gonna become 1 here. And similarly for 2, it's gonna be, all of them is gonna be 0 at first. Here 2 is gonna be 0 at first, but because we come across a 2, the j is 2. So if you know how to iterate through an array, since this particular prerequisite array is actually an array of lists, right? So and this list consists of 2 items, I and j. So as we iterate through, for each j that we get, we come and index it in this in degree and increment it. So as we come to 2 as well, we're gonna come and find the index of 2, and the element at that index we're gonna increment it. It's gonna be give us 1 because it's 0 by default. But because we come across another 2 again, it's gonna give us 2, right? So as we come across 4, 2, it's gonna give us 1, and because we come across another 4 again, it's gonna give us 2. So this demonstrates the edges, right? And that's how we create the in degrees. So now, okay, having the in degrees already created now, right? So now let's start. One thing we make known and we clarify is that we're gonna start with those that have an in degree of 0, and we can simply do that by iterating. After we have created and populated our in degree with the real numbers, right? After iterating through the prerequisite and populating the in degree, we are gonna iterate through the in degree and get each 0. Anywhere we find the 0, right? So it means that that particular course does not have any prerequisites beside it, meaning that it does not have any edge connected to it, meaning that we can always do them at first. So we are gonna go get them, and we are gonna be using a queue to store these particular courses, right? So storing them in a queue, when we iterate, we see that index 0 and index 3 actually have 0 as their in degree, so we can go do them straight up. So we're gonna save them in a queue, and what we're gonna do is that we're gonna pop out of the queue. So we are gonna be using a dequeue, right, so that we can pop left. So well, if you have a look at my previous video, you understand what I mean by dequeue. Dequeue is actually a module in Python, right, so that you import from collections. You say from collection import to the queue, and what it does is that it just simulates a queue and added some functionality to it. Like now, normally, we can pop out of an array, right, so to get the last element out of the array. But using a queue now, you can pop left, and pop left is gonna get the very first element out of the array, so which simulates the real world behavior of a queue, the first in first out functionality, right? So meaning that for a queue now, it's just like you are queuing for at a station, right, or at a cafe, and then the person that get there first will be the one to get there and to get his work done, right? So that's what this queue is just gonna do. So it's gonna get us 0, which is the first one that actually got into the queue, because 0 and 3 actually have their in degree set to 0, right? So we are gonna first pop out 0, and that's what you did right here, right? So popping out 0 now, we are gonna reduce the in degree of every one of everything that depends on 0. We are gonna reduce their in degree by 1. Imagine what I'm trying to say is that look at this cos1 now, because cos1 actually has cos0 as a prerequisite. Now it's gonna be reduced to 1, and its in degree is 1. It's gonna be reduced to 0. Why? Because now cos0 have been done, so the in degree of all the dependent have to decrease by 0. So similarly, after doing that now, also you will see that cos2, similarly we see that cos2 also depends on cos0, right? So we reduce its in degree by 1. So actually cos2 depends on cos0 and cos1, so reducing that means the in degree is 2, right? So reducing that by 1 makes the in degree of cos2 now 1. So and then after that, that's why we have this new in degree. See that we have updated it to 0 and 1, because cos1 depends on cos0, and because we have actually removed cos0 from the queue now, mean that it has been enrolled. We have enrolled for that. So and because of that, we have to reduce the in degree for cos1 by 1, and similar thing applies to cos2. So and right now we have our queue. So inside our queue, one thing we are also gonna do is that, because when we remove and reduce the in degree of cos1 by 1, right, it becomes 0. We are gonna append that cos1 into the queue. Why? Because now we can enroll for it, because it does not have any in degree any longer. It only has, it's actually 0, so mean that it does not have a prerequisite, right? So we are gonna reduce we are gonna add cos1 to the queue, because it has an in degree of 0. So and then what we're gonna do again is that we're gonna just keep on popping again, pop the latest cos from the queue, which is cos3. So by popping cos3 now, because it has an in degree of 0, right, so popping cos3 away from the queue now, we are gonna have everything that is depending on cos3, which is this cos2 for instance. Now we have the in degree reduced by 1, and because it's 1, so its in degree reduced by 1 and become cos2. So what we're gonna do is that we're gonna append cos2 again into the queue, right, because it has an in degree of 1. So we just keep doing that again and again. So imagine having adding cos2 into the queue. So and then by that we are just gonna have this remaining structure returned, right? So this will be the remaining structure that we will have. So and then cos2, because cos2 have an in degree of 0, is gonna be added to the queue again. So now the queue is gonna be like something like it's gonna be something like this, 1,2, right? So we are just gonna keep on popping again. We pop 1 again, and when we pop 1, we see that the in degree of 4 is gonna reduce by 1, and when we pop 2, we see that in degree of 4 is gonna reduce by 1 again, making it 0. So that way now we will be able to add 0 and 4 into the queue, and we just go on like that until we have consumed all the courses. So and by that it means that yes, we can enroll for all the courses, so we return true. So we're gonna see more about it in the code implementation. Look now, to summarize what I just talked about, the first step is that if we've processed all n courses, then enrollment to all courses is actually possible. But if we are unable to process all n courses, then enrollment is not impossible, meaning that if we get right here now, we just end up with when we process cos 0 and cos 1 and cos 2, because they have an in degree of 0, so automatically the in degree of 4 is going to become 0. So it's going to reduce by 1 for each cases, so it becomes 0. And the meaning that we can now add 4 into the queue and process it, and because of that the in degree of 5 is also going to become 0, and that way means that we have actually processed all the courses. But in a situation whereby you cannot process all the courses, maybe just like this example whereby it's not possible right here, so whereby there's no way we want to proceed because there's no course with an in degree of 0, we just return false in that case. So let's go into the code implementation for a more better understanding of the logic I just described. Alright, let's get into the code implementation for the prerequisites problem, DSA problem. So fine, we're gonna be calling our function prerequisites, and then let me write the parameters. So the parameters include the number of courses, right, and the prerequisite lists, right? So and now meaning that we're gonna be collecting n, which represents the number of courses, which is an integer, and also the prerequisites lists, or let's call it prerequisite list, so which is also a list of integers, right? So and then the return is gonna be a boolean, so of true or false, whether all the courses can be enrolled. So first of all, let's define the in degree. So we're gonna be populating the in degree to be zeros, right? Because later we're gonna be repopulating it, but we want to first of all populate it so that it can be of the size of n. So for underscore in range of n, so we have populated our in degree to be 0, so meaning that it's for n equals to 390, it's gonna be 3 zeros. So now to really know what the in degree or how many edges are connected to each courses, we are gonna iterate through the prerequisite list for I comma j in prerequisite lists. So what we want to do is that we want to populate the in degree by saying that in degree of j plus equals to 1. So meaning that each time we come across a pair of A and B, of I and J, right, whereby for J to be enrolled, I need to be enrolled. Now because of that prerequisite of I that J needs, we're going to be increasing the in degree of J by 1, so that we can know that okay, J actually depends on this so amount of courses or edges, right? So that's what we are doing right here. Now after doing that, now we need to populate our queue, right? So queue is gonna be populated with the first set of courses that have 0 in degree, meaning that we need to iterate through our in degree to find those courses that their in degree is 0. So we are gonna iterate through the index and then find the courses that have 0 in degree, so we can add them to the queue and start the queue proper. So from collections import the queue. So don't forget I said we're gonna be using needing the queue method. So we're gonna use it to create our queue. So I can create the queue like this, queue equals to the queue like this, right? So now let's iterate through the prerequisite list through the index, and this is how we do that for high in range of fine. We know that the prerequisite the in degree is what we want to iterate through, so as to find those particular indices or courses. Don't forget that the course is the same as indices, cos 0 index 0, cos 1 index 1, cos 2 index 2. So and then the in degree of each courses, we just want to find out those courses that have in degree of 0. So definitely we can enroll for those courses first and we can add them into the queue, right? So I'm gonna say for I in range of n. I could have used for I in range of len of in degree, but in degree and n actually have the same size, so I can just use n. So for I in range of n, if in degree of I, if it's actually equals to 0, that is, they actually have no dependence, they are not depending on anything, then we want to add them to the queue dot append such a course I, right? So don't forget that the index also actually represent the courses. So now, having populated the queue at first, so we are gonna keep on doing this particular loop until there's no more courses in the queue, so that way now we can easily find out. So one thing again is that let's set a variable enrolled to be 0. So this one will help us to tell we'll be increasing our variable enrolled by 1 each time we try to pop out of the queue. So that way at the end of the day, when the queue becomes empty, you can easily check if enrolled is equals to n, that is, if each of the courses are actually enrolled. So if it is, then we can return true. So why queue? First thing I want to do is I want to increase our enrolled by 1. So why? Because we are about to pop out of the queue. So for each pop, we're gonna be increasing our enrolled by 1. So, and now we're gonna say course URSA, course equals to q dot pop left. So pop left is just gonna help us pop the first courses that actually have their in degree cost to 0. So popping out this now, what we wanna do is that we want to iterate through our prerequisite list, prerequisites prerequisite list. So, and we're gonna see for I comma j in this list, right? So if I is equals to course, meaning that if we are trying to iterate through all prerequisites that actually have this course that we popped out as a dependent or as a requisite. So if I is equals to course, definitely we want to reduce the j in the in degree by 1. So this way now the in degree of all this, imagine course 0 now, because course 1 depends on course 0. So for us to enroll for course 1, we have to enroll for course 0. And now because we have been able to enroll for course 0, so we have to reduce the in degree of course 1 by 1. And how do we enroll for course 0? We actually added this into the queue and we pop it out, so it's no more in the queue, it's no more part of the courses anymore. So we have to reduce the in degree of every course that depend on 0. We have to reduce the in degree by 1. So in degree of such a course j minus equals to 1. So now we want to check if the in degree of such a course is 0, maybe by subtracting on and on. The in degree of such a course is equals to 0. Definitely we can enroll it now if it's equals to 0. So we can just enroll it into the queue dot append such a course j. So this is just what we're gonna be doing. So, and then we just keep doing this on and on until there is no more course in the queue. So now when there's no more course in the queue, there's two probability. So it's either we have exhausted and enrolled all the course, or probably that set of courses cannot be enrolled all at a time. I mean, probably there's no way we can enroll all the course in the all the course, right? So, and how we can know which of it actually is valid is that we just return enrolled is equals to n. So what I just did simply here is that because each time we try to pop a course from the queue, so a course that is popped from the queue necessarily would have been added to the queue, right? So each time we're trying to pop a course, we increase our enroll by 1. So now if the enroll increase by 1 3 times, maybe that is the enroll becomes 3, definitely we want to check if n is also 3. So if n is 3, that means that every course have actually been added and popped from the queue, right? But if it is less than, if the enroll is less than n, definitely it means that there are some courses that have not been enrolled and could not be enrolled, probably because their in degree cannot get to 0. That is, they actually have some dependents that are not being enrolled. So meaning that such a prerequisite such courses cannot be enrolled, all of them cannot be enrolled, right? So that's what we're just trying to do here. So after everything, we're just going to check if enroll equals to n. So if n courses are enrolled, definitely all the courses have been enrolled. So let's run this code and see how it goes. So we are expecting a false. So here we can see a false here. You might see two falses. So two false. There's one false here and there's another one here. So it's because most of the time I used to write the code and prepare it so before I come online, so there won't be much mistake or error handling. So I studied it beforehand. So this is how to solve this problem, and I really hope you understand. So if you look at the problem statement, you will see that false is also returned, right? This is false here. So but let's try to look into this particular prerequisite now. Let's try to look into it and see. This one should give us a true. So let's see. So I'm just gonna do it like this. So I'm gonna do this prerequisite list. I'm gonna copy it here, paste it here. So let's run it now. So we should be expecting a true. So don't forget that if you look at the problem logic, this particular example should give us a true because it doesn't form a cycle, right? So and this is it here. This is the true. So this is how to solve the problem, and it works for all cases. So and I really hope you understand this. If you do, kindly subscribe to my YouTube channel, please. Thank you guys.